Hi and welcome to this video on vectors, maths made easy, GCSE level. Now a vector has both magnitude and direction, so if we have this from point A to point B, we draw a line, and then the direction of the vector is given by this arrow, and the magnitude is the length of the line from A to B. When we're referring to vectors, we write them as A, B, in capitals with a line over the top or an arrow over the top signifying the direction from A to B. We're usually given it in an exam as a bold letter like bold A, little a. We write it as a little a with a line underneath or a squiggly line underneath. And also we can write vectors as column vectors where the top number is the horizontal distance and the bottom number is the vertical distance. So for instance from A to B, the horizontal distance is 3 units, 1, 2, 3, so that's the top number, and the vertical distance is 1, 2, 3 from A to B, and that's the bottom number. If we're going in the opposite direction from B to A, we write that as capital BA with an arrow signifying that's the direction we're going from B to A. Now the vector would be, we're going in the opposite direction of A, so it would be minus A. And also the column vector from B to A, we're going minus 3 units down, so this bottom one would be minus 3, and we're going minus 3 units across, so the top one would be minus 3. So top is horizontal, bottom number is vertical. Now if we've got two vectors A and B and we want to add them, what we do is we place the tip of the arrow to the base of this one, so top to tail. Okay, so we can then follow through with the arrows in like so. So drawing it graphically, we can follow the arrows, so the tip of this one to the base of that one. So from this we keep the direction the same and the length of the line the same, so direction and magnitude remain the same. Place them to the end of the vector A, and then we draw a triangle, and this resultant, this is called the resultant, it's A plus B, so this would represent the vector A plus B. The arrows represent the direction, and the length here of this line represents the magnitude of the vector A plus B. Now if we're doing the same but subtracting, so again we've got the vectors A and B, so we want A minus B, so we need to turn this arrow the other way round, so we need to reverse the direction to make it minus B, A minus B, and then move it so that this arrow is to the tail of this arrow, like so. Let's just do that. There we go, reverse direction, but the magnitude remains the same, the length of the line remains the same. Okay, so from here to here, and then we draw our triangle, and this is the resultant. The arrows represent the direction of the vector, and the length of the line represents the magnitude of the vector. So in summary, when we're adding and subtracting vectors, we always place the vectors end to end so that we can follow these arrows. Okay, we've written it's AB, vector AB plus vector BC equals vector AC. So let's write that vector in. So that's the resultant vector AC, or A plus B. And in column form, we can write A to B as vector 2, 2, so it's 2 across 2, 1, so that's 2 across 1 up, plus vector BC, which is minus 2 across 2 up. Then we add these two, so that's 2 plus minus 2 is 0, 1 plus 2 is 3, and this is vector A to C. And as we can see on our graph, A to C, there's no horizontal shift, that's 0, but there is a vertical one of plus 3, so the bottom number is 3. The magnitude of vector is given by the length of the resultant, so here we got the resultant vector as O to C, and the magnitude we write as these two lines on the either side of OC, and this is the length of this line OC. So if we have vector OB is 3 and vector BC is 4, and this is a right angle, we could use Pythagoras to work out the hypotenuse, so to work out this length and hence the magnitude of OC. So a squared equals b squared plus c squared. So this hypotenuse, the length squared, would equal 3 squared plus 4 squared, and using Pythagoras we work it out to be 5. The triangular law of vectors. Now let's look at this triangle that we've drawn here, which is vector OB, B to A, vector BA, and then A to O, vector AO. So the triangular law states that if we have this O to B, B to A, and A to O, which forms a triangle, the net result is 0. So we don't move from 0, we return to this O. Okay, so OB plus BA plus AO, those vectors, the sum of them equals 0 because we haven't moved. Okay. Now if we rearrange those, we get vector OB plus BA. Vector OB plus BA is the negative AO, so it's going to be this arrow reverse the negative of A to O. And the negative of A to O is O to A. So we can write as minus A to O equals O to A in vectors. So now we can rewrite this as vector OB plus BA equals vector OA. So drawing this as such, the triangle law of vectors, it states that in a triangle, the sum of two vectors in the same direction, so that's OB to BA, is equal to the other side going in the opposite direction. So this is quite important because sometimes rather than being given these two vectors, we can be given the resultant vector and another vector, and then to find the third vector we have to subtract from the resultant. So if we were asked to find vector B to A, we'd have vector O to A minus vector O to B. So we've represented that here. We have to find vector A to B. So vector OA, this is OA, plus OB, plus AB would equal OB. So we're going to draw that in this form. So we can see that these two are our vectors that are continuous. So this is treated as our resultant vector. Okay, so vector OA plus AB equals vector B. So A plus AB equals B. So vector AB equals B, which is this, like we said, the resultant vector minus A. Sometimes we can be given a question where we have to find, or we're given, rather than the vector, we're given it the ratios that the vector's in. So first of all, we're given OB and OA and asked to find A to B. Now A to B is B, which is the resultant, minus A. So remember we said if we have these continuous ones in the triangle, then the opposite, or the vector going in the opposite direction is our resultant. So we want to minus A from our resultant to give us A to B. So A to B, vector A to B is B minus A. Now they tell us that the point M lies on A to B, and the ratio of A to M to B is 2 to 1. And we have to find OM, so this is O to M in terms of A and B. So to get from O to M, we're going to go in this direction. We're going to go O to A, which is A, and then a to m. And then we know that a to b is b minus a, so a to m is going to be 2/3 of a to b. So vector o to m equals o to a, which we said was this one, a, plus 2/3 of vector a to b. Now we know that vector a to b is b minus a, so this becomes, and o to a is a, so this becomes a plus 2/3 b minus a. Multiplying out these brackets, we get a plus 2/3 b minus 2/3 a minus 2/3 a is 1/3 a, so this becomes 1/3 a plus 2/3 b. The parallelogram rule, similar in fact to the triangular rule, but we have to think of the resultant as the diagonal of a parallelogram. So here we've got two vectors, a vector A and a vector B, and we usually measure from the x-axis, and we usually measure in this direction, which is anti-clockwise. So this is 50 degrees from the x. This vector A is acting, there's a load of 60 newtons acting at 50 degrees, and vector B is 20 degrees, or rather minus 20 degrees, and we've got 80 newtons acting in this direction. We can move this vector B up to form the other side of a triangle, so keep the direction the same, keep the length the same, and move it so that we've got the tail to the tip of this vector, like so. And then our diagonal, so we're going to form a triangle, it will be our resultant vector. Now if we look at this, we form a parallelogram, and we can see that when we form the parallelogram, this vector B is parallel to this parallel vector A is parallel to this vector, which is the other side of the parallelogram, and the diagonal of the parallelogram is the resultant vector A plus B. Now notice that this angle, this total angle, we were given as 70 degrees, this 50 plus the 20. So that makes this angle here 70 degrees because it's a parallelogram. So then we can work out these other two angles, because the four sides of the parallelogram add up to 360 degrees. So 360 minus 70 and minus 2 alpha equals 360. So we can work out 2 alpha as 220 degrees, and then this angle alpha is half that, which is 110. Now that we've got this angle here as 110 degrees, and we've got two sides of a triangle, we can use the cosine rule to work out the resultant, which is the other side of the triangle, non-right angle triangle, cosine rule. And using the cosine rule, we get this AD squared equals 60 squared plus 80 squared minus 280, 80 times 60 cos this angle, which is 110 degrees, and that gives us this resultant vector. Now we need to work out the angle here, angle theta. So how do we do that? So first of all, we work out this angle beta using the sine rule, because now we know this side, we know this angle, so we can use the sine rule. So we know this side, and we want to find angle beta here. So using the sine rule, we get angle beta, and then this angle theta is merely 50 degrees minus angle beta. If we have a vector, this vector f, it can be split into two components at right angles, and the vertical component is f sine theta, and the horizontal component is f cos theta. Okay, and theta is measured counterclockwise. It's measured in this direction, anti-clockwise, from the x-axis, from this axis. Another way of thinking about the parallelogram rule, let's just go through that and get another equation for that using this total angle theta between vectors b and a. And this parallelogram, we extend the line to a point E, and this drop a line from this D, a vertical line, to form another little triangle here. And we're going to use this big triangle A, D, E, A, and Pythagoras in our calculations, in our working out. So using this triangle, AD squared equals this A to E, which is AB plus BE squared plus DE squared. So we're using this triangle Pythagoras. Multiplying out this bracket, we get AD squared equals AB squared plus BE squared plus 2AB multiplied by BE. So we multiplied out this in brackets and then plus this DE squared. Now remember what we said about the horizontal and vertical components that we can split this into. So using that rule, we get B to E is B cos theta, D to E is B sine theta. So BE squared plus DE squared is B squared cos squared theta plus B squared sine squared theta. And then because this is B squared theta cos squared theta plus sine squared theta, this is essentially 1. We're just left with B squared. Therefore, BE squared plus DE squared equals B squared. Now we go back to here, and we get AD squared is AB squared, which was A squared, plus this BE squared plus DE squared, which is the B squared. So that's B squared, plus, and then this 2AB multiplied by BE. So this 2AB plus BE is merely 2AB, A to B is A, 2A, and this BE is B cos theta, so that's 2AB cos theta. So this is our rule, our parallelogram rule we can use when we know this angle between the two vectors, this angle theta. So AD squared, the resultant, is equal to A squared, this vector plus B squared plus 2AB cos theta, theta being the angle between the two vectors. Then tan alpha, this angle that we need to quote, because that's the angle the resultant is going in, that's the direction, is given by B sine theta, which comes from this triangle, divided by tan theta equals B sine theta, tan equals tan theta equals opposite B sine theta, should be this one, over adjacent, which is A, this, plus B cos theta. Okay. Sometimes we can be given real life vector problems. Sometimes we're given, this is like an airport, the wind is blowing in this direction at a rate of 30 kilometers per hour. And this airplane, this Qantas airplane, is trying to land. It's going in a straight line, but the wind is blowing it from this side, from left to right, at a rate of 30 kilometers per hour. So it's going to be shifted. The direction of the landing is going to be shifted as such, as shown in this vector diagram. So we can use Pythagoras to work out the overall speed. So the overall speed using Pythagoras will be square root of 30 squared plus 100 squared. And the direction, tan theta, so tan is opposite, which is 30, over adjacent, which is 100. Sometimes we can be given the same kind of question, but in a different format. We still got the wind blowing, and this airplane then tries to land exactly along the runway, but it has to do so because the wind's blowing. It has to follow this direction. Okay, it has to follow this vector, and because of this force, this vector acting in this direction, it goes thus and follows this path. So what's this angle theta that it has to follow into the wind to be blown this way? And we get that from sine theta, so that's opposite over the hypotenuse. Sine theta equals 30 divided by 100, and the speed from Pythagoras' theorem is square root of 100 squared minus 30 squared. This is another classic question we can be asked, and we have to work with two vectors. We've got two tugs towing a large tanker. This is the x and this is the y axis. This tug is tugging in this direction 40 degrees, and this tug is tugging in this direction. Remember, we've measured clockwise, so this is going to be minus 50 degrees. Okay, it's not 50 degrees, it's minus 50 degrees because we measure from x in a clockwise direction. Okay, so now we have to split these vectors into x and y components. So the x component of tug A is going to be 10,000 cos 40. The y component, which is this vertical component, is going to be 10,000 sine 40 degrees. So we'll work that out here. For tug B, which is this one, it's going to be 15,000 cos minus 50. So this is going to be the y component this way, downwards. And sorry, that's going to be the x component, xy. So this is going to be the x component, 15,000 cos minus 50. So x component, and then the y component, which is downwards, is going to be 15,000 sine minus 50. So that's worked out here. Then we add the two x values and the two y values, and we get 17302.254 newtons as the x and minus 5062.79 newtons as the y. Draw this as our vector diagram. So this is the x, this is the y, and this is going to be our resultant force. This is our resultant vector. We can find the magnitude, so that's a plus b by Pythagoras, because we know these two sides and we want to find the hypotenuse. This is a right angle. And we can find this angle theta by using tan theta equals opposite, which is here, over the adjacent, which is here.